Hello everybody, getting ready to do lesson 1.4 of pre-algebra math, part 1. Comparing and ordering integers. We have a 38-point skill sheet here, and then we have a 22-point notebook guide available for this lesson. Here is our standard, here are the objectives up here. And then teachers, here's our bell work for this lesson here. We have a word problem, cell phone service, equally write expression for your share of a bill when you are charged for M extra minutes. So go from a verbal model into an algebraic model. And then for B, apply 1 month you are charged. So actually then plug in values here, students, for this. Give your students 5-6 minutes for this. Okay, welcome back. And here is our verbal model here, monthly fee, cost per extra minute times the number of extra minutes. So we have our monthly fee and then the number of people here, 39 plus 30 cents per minute of extra minutes over 2. That would be our verbal model going into an algebraic expression. Apply 1 month here, so when M equals 125, so you only have 125 minutes here in this situation. Then we have 39 plus 0.3 times 125 over 2, and it would be $38.25 going from our verbal into our algebraic expression, and then plugging in this here. Yeah, that'd be your plug-in here for M. And this is what it would look like here in your algebraic expression divided by 2. And then your math would come out like this. 76.5 divided by 2 would be 38.2. Okay, into our lesson here, supercooled insects. Students, this is your notebook, page 1. This is your entry into your notebook. And we're talking about insects. About body temperature of insects, which of the insects listed in the table has the lowest supercooling point. So we're going to go to a table. A lot of this lesson concerns about reading a table. Here are different kind of species here of insects, and then their supercooling points here are varied. They're varied kinds of physiologies here. So they're negative integers. The integers are numbers here, negative 3, 0, 0, 1, 2, and 3. So integers are counting numbers which include negative counting numbers. These are 1, 2, 3, including 0. We include 0 into the set of integers, but there's also negative numbers that are included in the set of integers as well. And then they continue without, and this is an ellipsis here. That means it just goes and goes and goes, and this is the other side. And that goes and goes and goes with negative integers and positive integers. Hey, so our integer is greater than 0. So here's a number line here that displays positive integers and negative integers that way. Students, in your own words, define integers and then define negative integers in your own words. This is your notebook entry, page 4 on this lesson. And then we have positive integers and then absolute value. We've covered absolute value at this point as well. Okay, back to our supercooled insects here, graphing and ordering integers. So graphing these quantities here on the number line would look like this here, negative 9, negative 19, negative 35. Here is our origin, here is 0, but all of our plots here are negative, so they go in a number line in this direction here. So that's basically what this is about here. This is classwork. This is your classwork sheet, page 6. There is the origin, and then we go into our plots there. In case you're having trouble finding that on your classwork sheet, you should have a number line, and then fill in these values here on your number line. It's important to learn how to make these plots on your number line. At negative 70, the woolly bear caterpillar has the lowest supercooling point, negative 70 degrees Celsius. So that would be the winner of that contest there. Okay, determine which insect in the table above has the lowest supercooling point. Graph integers on a number line. So here again, we're graphing these things. And then we come out with the woolly caterpillar. That's the one. Okay, so now into our first guided practice here. Students, this is your independent practice here. This one's on you to plot these. We're going to plot these in our guided practice. And let's see here. Okay, so the absolute value, I guess we're not. That's up to you too, students. The absolute value of a number is its distance from 0 on the number line. So this goes back to your definitions. Here's your definition, students, to go back in your notes on that definition of absolute value. The absolute value of number A is written like this, so you got two brackets here. You can use the number line to find the absolute value of a number. So it's really the distance from 0 is the absolute. So find the absolute value of 5 here. What's the absolute value of 5? Well, how far is it on the number line? It's 5 units from the origin. So the absolute value of 5 will be 5. So that would be 5. The distance between 5 and 0 is 5, so the absolute value of 5 would equal 5. Here's the absolute value symbol for that. And then state the absolute value of the number here. So we have -7. What would be the absolute value of -7? Here's the plot here of -7. We're to the left of the origin, 7 units here. So the absolute value of -7 would be 7. The absolute value of -7 will be 7. Okay, again, into our guided practice, and this is yours down here regardless. State the absolute value of this number here, students. What's the absolute value of -12? Well, see here. Absolute value -12. How far is -12 from the origin? Absolute value of -12 is 12. It would be way out here somewhere. It's not included here. Or you could say these are 20s here. So this would be -10, -20, -30, -40, etc. So -12 would be right about here. And then you can like graph that if you're real cool. If you're a good student, that's what you would do right now. And that is our lesson of lesson 1.4, part 1. Part 2 and part 3 are available here, as well as worksheets and solution PowerPoints. Thank you.